Hi all, this is Rajasanan. In this video, we are going to discuss about the principal component analysis and a few of the interesting applications of it. Principal component analysis. It is commonly used in dimensionality reduction. All features are axes and each row form a single coordinate in the n-dimensional plane, where n being the number of features. PCA transforms or forms new axes such that it tries to explain maximum variance. Each axis that it forms tries to explain the maximum variance of the data. The axis that forms first will explain the maximum variance. The axis that forms the last will explain the least variance. So, the axis that forms the least variance could be neglected and thus achieving the dimensionality reduction. So an interesting aspect of this PCA was what would happen if it is applied to an image. An image being a data which is being stored as an array of RGB, each from 0 to 256. It is stored as a three-dimensional array. So even this could be reduced using the PCA. So what happens to an image when a PCA is applied to it? So it essentially results in image compression. So we are basically going to look into it, how that one is possible. So I have written a couple of code here which helps us do it. So let's see the working part of it, of how it is being done. So these are the sample images that I have, and I'm going to be running the method that I have created, where I would be telling the PCA to retain 95% of the variance. And let's just run this. And it is asking me whether to delete the files that are already there. I would just say no, I don't want to delete it. And if you see, the new files that are formed and download is of 9.16 KB, whereas the original file is of 11.8 and so on. So what if I mention here 99% or maybe 98%? What would happen? I run this, and then are you sure you want to delete the file? Nope. Then we see there's another folder that is created with about 98%. So yeah, so in this way PCA could be used as an image compression tool. So one thing that has to be observed here is that once every image is comprised of R, G and B, and you read it like this, it will give you the RGB component of an image. Once that is done and you apply a PR comp, it is just a function in R which directly gives you the principal component of that particular RGB. And one thing which has to be noticed, that image correction has to be done. What is image correction here? Certain numbers in the principal component will go in negatives, and colors are not explained in negatives. So those negatives should be converted to a 0. So that sort of image correction technique has been handled here. So yeah, PCA component can be used for image compression. So this is it. The code for which will be uploaded in GitHub, and the link for the GitHub will be provided in the description below. Thanks for watching.